Welcome to another Great Cloud Basic demonstration. This is part 2 of a suite of videos I'm making on the 16F171 chip family. Hi, let me just turn my camera on. Hi, my name is Evan Venn. I'm a co-developer of Great Cloud Basic, along with a huge team of other people that develop the compiler and toolchain. And I feel like we need to get the message out with respect to this new chip. So let's get into this. We're going to go through it quite quickly. What is this chip? It's a new chip that's just been released. I got one in the mail last week, so I thought it was worthwhile showing it to you. The chip itself is a high performance chip, as you can see on the screen. It's got digital ports, 12-bit ADC, multiple communication interfaces, pulse width modulation, 16-bit, very nice, CLC in terms of configurable logic cells, and a very nice op-amp, which we'll come on to much later in another set of videos, and it comes in a small footprint size. The videos we're going to look at today is about making 4 LEDs flash in sequence, and I'll take you through how it works, and then we'll put it into action. So, got a message overnight, email overnight. It's about connectivity. How do I connect my PIC kit to the chip? Better diagram today. And you can quite clearly see that this diagram shows us a better picture of the 5 connections that we need to put on the between the PIC, okay, and the programmer. Let me just bring in my ballpoint pen here. I've got a connection to, I'm using 5 volts, connection to ground, connection to the master clear, and this one has been pulled up via a 10k resistor. And then I've got my data line and my clock line connected to my PIC kit. And this is the minimum that you need. You should also have a capacitor across here. And if you look at the data sheet, it shows you that capacitor value. However, I'm using a microchip low pin count demo board. It's quite an old board, they're readily available, and in the PDF it shows you how to do the same connectivity. Also yesterday we looked at doing this on a breadboard, and you can look at this diagram in slow time to create your own copy. So we should be able to get you up and running with this chip extremely easily. Now, let's recap what we covered off. We downloaded and installed GCStudio with all the default values. We attached the microcontroller to a suitable board, and then we validated some communications by doing some programming, by making an LED operate. So let's have a quick look at the lab cam here, and this is where we sort of left it yesterday. I'm using a PIC2. I've got the chip installed here. I've got 4 LEDs, a potentiometer, and a switch. And what we're going to do today is make these LEDs flash in sequence. We will develop this over the next set of videos to give it more capabilities. Back to PowerPoint for a second. Let's get my pointer back. So, how do I make 4 LEDs flash in sequence? Well, it's quite simple in reality. We need to do these steps. The steps are quite simple. We need to initialize the chip. We need to set the first LED. And then we're going to wait. I think we're waiting 1 second. And then we use a command called rotate. And we rotate the LED 1 bit. So it moves from the first LED would be set to the next LED. And then we have a thing that says, did it overflow? And we're going to use a special flag to see if a number overflows. I'll come into that in a moment. And if it did not, it goes back, does another delay, and then rotates again from the third LED to the second, etc., etc. And if it did overflow, we just reset the whole sequence. And once we've reset the whole sequence, here, we just restart and go back to the delay. So we're going to walk through this in another diagram to make it a bit clearer. This is rotate with carry. Let me understand. So we are going to move a value of 1 from LED 4. Where's my mouse here? Here it is here. From LED 4 to 3 to 2 to 1. And if it carries, I'm going to reset and restart the whole sequence again and carry on and carry on. Let's walk through this in using a bit of color. Set the first LED, rotate. And if you notice at the top here, there's a little register flag up here in the top right hand corner, and it shows you how the flag is what's happening in the register. Then we rotate. The little LED in the register has moved, the bit has moved. I rotate, it moves again, and the last rotate, it actually sets what's called the carry flag. And we can test for the carry flag. And if the carry flag is set to 1, we know it's overflowed. We can then restart the sequence. So we end up back at the start and we carry on. And so it's quite simple. Let me come out to my desktop and show you this in action. All right, clear desktop. The reason I've cleared my desktop, I've exited the editor, the IDE, and I'm just going to restart that by pressing the Windows key. GCS will bring me into GCStudio on my menu. I can see it, it's come up and it started GCStudio. What is important about restarting it, you get this menu. You get a different, the first time it goes in, it takes you directly into the IDE. The second time you start it, it will come up with the screen that looks like this. Let's just keep this quite simple. It remembered that we were looking at on the left here, it remembered what we were working on yesterday. If I click that, it will take me directly to that folder. It will set up the IDE where I left it. One of the big advantages of GCStudio, it remembers what you're working on. That's where we left it yesterday. We have the blinking video. We have a program called Blink. It was operating and it is operating on the board. These are all the programs I was using yesterday on the left hand side, and this is a console that's closed up. Let's just close that console. We don't need that. So you can just shut that down when you're good and ready. This is the program we were working on yesterday. Let's close that one down to clear the editor out. We end up with a cow. Now, IDE training. Press F4. We pressed that yesterday. If I press F4 and I type in the word clean, it will clean up the folders on the left-hand side. Oh, it won't, because I have to have a file open. If I've got that open, I can type clean, and it will purge out all the files that aren't needed in your project. And we don't need lots of files that the system creates once you've actually done the work. Let me close that window down. I'm going to open up 040, rotate the LEDs. Let's have a look what we're doing in here. Program. We close down the left-hand Explorer. Done. Zoom in so you can see it quite clearly. And then walk you through. You've seen this before. Hash chip 16F17126. Option explicit, good practice. In my diagram here, I've said I've got 4 LEDs. This is just information. I've got 4 LEDs on port C, and they're on port C 0, 1, 2, and 3. That's where the LEDs are physically located. That's documentation. I've defined a constant called LED port, and that is lat C. Could be port C, call it what you like. And then I've said I want my 4 LEDs to be out. So RC 0, 1, 2, 3, and 4 are all set to out. Then, like in the diagram, I'm going to initialize my port, and I'm going to set it to the value of 8, and that will turn on the first LED that I want to set on. And here's a binary representation of that, and it will set it to 8. This is 8. That's binary 1000 is 8. It will then set the LED, one LED on at this particular port. And here is the main loop. Let me zoom just so we can see it. Here's the main loop. Wait for one second. Let's just change that to second. Wait for 1 second. Clear the carry because we need to ensure the carry is empty. We're going to rotate the LED port. This is the rotate command, and that will shift the bits and the contents of that register to the right. We can then test the carry, and if the carry is set to 1, we restart the whole process. Let's look what's going to happen. Here's the camera out into the lab. I'm going to press the icon in the top right hand corner, which is make hex and flash, and we'll see it do it. 6 seconds. That's because I'm doing a lot of processing in the background here for all the graphics, and you can see that the LEDs are flashing exactly as we expected. Now, we have created a very simple program that is highly portable. What I mean by that is that this will work on the vast majority of PICs and AVRs with no changes. And all you have to do is change the hash chip statement. But I'm going to show you how to do this in assembly. This is the next level down from the basic language we're looking at now into assembly. So I'm going to open up the Explorer, Control B, or press the little page icon, rotate. Look at this demonstration here, which is 040, rotate the LEDs using ASM. And if I click on it, I bring it into the editor. Close down the Explorer, and now I've got the same thing. Now this time I have to add in, because it's assembler, I'm showing you this purely for demonstration to show how easy Great Car Basic is. I have to put in specific codes that are very specific to this trip. I have to clear things. I have to use a very abstract language called assembly, and Great Car Basic supports assembler. And it uses a set of languages that you'd have to learn. The beauty is that Great Car Basic supports assembly. If I press F5, it will program it. Oh, it doesn't. It said there's an error in my program. I truly believe that that is because start is specific. That error was shown there is specific to this chip. And if I did it on another chip, it would be fine. So I will delete that. As you can see, the LEDs are operating at a different speed because I have to calculate the value of the delay. I have to calculate in assembler, whereas in our language, if you want to change the delay to 500 milliseconds, you just change it like this. Reprogram it. I'm going to minimize that from now on because I'm not interested in it. Now you can see that the LEDs are faster and faster. I'll just change that. Tomorrow we will just change in the next video, we will then change the rotation of the LEDs using the potentiometer. Great, there we go. Let's recap what we've seen. We've seen that we can define constants. We can set the multiple ports inputs as outputs. We can set a port to a particular value, and then we can do a do loop to rotate the LEDs. Fantastic. So let's look at what we're going to be looking at tomorrow. we're going to set the LED to represent the value of the ADC, so introducing more constructs with respect to the language. And with that, I think we'll call this a wrap.